This is notes for Unit 1, Lesson 6, Multiplying Fractions. Multiplying fractions is one of the easier things to do with fractions, if not the easiest, because really it just ends up being multiply straight across. So let's get into this one. It's pretty simple. We'll go through these notes and examples and go through a couple of example problems, and hopefully it'll be a pretty quick lesson. So, first of all, the rules. Number 1, write all mixed numbers as improper fraction. You already know how to do that. You multiply the denominator times the whole number, and then the whole number you add to the numerator. Multiply, add. And we'll do some of those. Then you can simplify up and down, so top and bottom. If you see a fraction that can be reduced, reduce it. I'll show you also what's kind of cool is you can reduce diagonally. And I'll show you that. And even if you can't do that or get confused, don't worry. It's not going to cause the problem to be wrong if you don't do it. But you may have to reduce later on when you get your answer. Then you multiply the numerators to get the new numerator. Then you multiply the denominators to get the new denominator. So in this case, the denominators do not stay the same. You actually multiply them. Then number 4, simplify again if needed, which means reducing the fraction if possible. So let's look at number 1. Now, some of you had a problem with this on the previous homework where they had a whole number and you're asking, hey, this isn't a fraction. How do I deal with it? Well, whole numbers are simple. You put a 1 under them. So what I have here really is 2 over 1 times, and the negative, I'm just going to stick it up here in the numerator. It doesn't matter where it is as long as it stays with that fraction. Then we just multiply straight across. 2 times negative 7, well, what's a positive times a negative? It's a negative. 2 times 7 is 14. 1 times 9 is 9. So that's almost my answer. It is, remember, that is an improper fraction. So I need to change that to a whole number. Well, 9 goes into 14 one time. My negative is going to come out front now. 9 goes into 14 one time with 5 left over after I take 9 out of 14. So I end up with negative 1 and 5/9. Okay. Example 2. Remember, multiply and then add. 7 times 1 is 7, plus 1 is 8. So I end up with 8/7 times 1/10. Now, here's the kind of cool thing. Neither one of those fractions can be reduced the way they're written, but if you go back up here on number 2, it says, and along the diagonals. So that means I can actually look at these two numbers. What number goes into both of them evenly? Well, 2 goes into both of them. So I end up with 8 divided by 2 is 4/7. The 1 stays the same on the numerator over there, and 2 goes into 10, or 10 divided by 2 goes 5. Okay, so if I have 4/7 times 1/5. Now, if that's confusing to you, don't worry about it. You will get a correct answer anyway if you don't do it. It just makes the problem a little simpler to work with. So now we go ahead and multiply straight across. 4 times 1 gives me 4. 7 times 5 gives me 35. And 4 over 35 cannot be reduced. That is my answer. This next one, number 3, a little more difficult, but not terribly difficult. Remember, multiply, add. Multiply, add. Now, what you don't need to worry about is that negative out front. Okay, we're just going to go ahead and put the negative out front. 3 times 1 is 3, plus 2 is 5, so I end up with 5/3. Times, I'm going to put that negative out front again. 3 times 1 is 3, plus 2 is 5/3. Exact same thing. So then, can I reduce either of those? No. Can I diagonally reduce any of those? No, there's no number that goes into 5 and 3 evenly, so they're already as low as they can be. So then we just multiply it. Now, we've got a negative fraction times a negative fraction. What's a negative times a negative? A positive. So now we know our answer is positive. You can either put the positive out there or not. I'm going to leave the positive out. It's just assumed it's there. If there's no sign, remember, if there's no sign, it's just assumed to be positive. Then we multiply straight across. 5 times 5, 25. 3 times 3 is 9. So we end up with 25 ninths. I need to reduce that or turn it into a mixed number. 9 goes into 25 2 times, that's 18. You subtract the 18 from 25, you end up with 7 left over, 7 ninths left over. There is our final correct answer. Let's look at number 4. Again, multiply, add. Multiply, add. So 2 times 1 is 2, plus 1 is 3, so we end up with 3 halves. 2 times 1 is 2, plus 1 is 3. I'm sorry, on the other side over here, whoops, made a mistake. 2 times 2 is 4, plus 1 is 5. This should not be an equal sign, it should be multiplication. 2 times 1 is 2, plus 1 is 3 halves. I'm sorry about that. Tell you, we all make mistakes every once in a while. So I don't have anything that I can reduce. 5 halves, I can't make that smaller. 3 halves, I can't make that smaller. I can look at the diagonals. Still, it's the exact same denominator, so it's not going to change anything. So I've got the fractions as improper fractions, and I can't reduce them anymore, so I go ahead and multiply straight across. 5 times 3 is 15. 2 times 2 is 4. That can be reduced or turned into a mixed number. 4 goes into 5 3 times. So 3 times 4 is 12. So if I take 12 out of 15, I end up with 3/4 left over. Okay? I'm going to also we'll do 2 more. So again, multiply, add, and that negative is going to stay out front, or I can put it with the numerator, negative. 7 times 3 is 21, plus 1 is 22 sevenths, times 3/4. Okay? Now, 22 sevenths, not reducible. 3/4 is not reducible. But this 22 and the 4, those can both be divided by 2. So now I can have 22 divided by 2 is 11 sevenths. And I still have the 3. And 4 divided by 2 is 2. So it just makes my multiplication a little bit easier. And again, you won't get it wrong if you don't do that part, if you're not comfortable with diagonal reducing, but you're going to have to reduce afterwards anyway. So anyway, now that we have everything reduced in improper fraction form, I can multiply straight across. A negative 11 times a positive 3 gives me a negative 33. And 7 times 2 is 14. Okay. And 14 goes into 33 twice, because 2 times 14 is 28. If I take 28 out, so I end up with negative 2. That's the 2 times the 14 went in. The negative stays out front. And then I take 28 out of 33. That leaves me 5/14. That would be my final answer, because there's nothing that goes into 5 and 14 evenly besides 1, and 1 does not help us. Last one. Again, don't get confused when you get a whole number. All you got to do, put a 1 under it. Okay, whole number, just put a 1 under it. That makes it a fraction, because negative 2 divided by 1 is negative 2. Remember, fractions are just small division problems. Got to multiply that, so multiply and add. So what we end up with is negative 2 over 1 times 4 times 1 is 4, plus 3 is 7, and it's going to be a negative 7, because there's a negative out here, 4ths. Now, can I reduce anything? Well, the 2 over 1 I can't reduce, 7 over 4 I can't reduce, but the 2 and the 4, I can reduce those. So that ends up 2 divided, well, it goes into 2 and 4, 2. Well, negative 2 divided by 2 is negative 1 over 1 times, and negative 7, and 2 goes into 4 2 times, so that's that. I just divided the 2 and the 4 by 2. So a negative times a negative, again, is a positive, so that's 7. 1 times 2 is 2. And we almost have our answer here. So 2 goes into 7, 3 times, because 2 times 3 is 6. I take the 6 out of the 7, that leaves me 1/2. Okay, that is my final answer, correct answer. Go ahead, try the odd ones. Try number 7, 9, and 11. Do 7, 9, and 11 on your own. And I will do, let's take a look at number 13, and then I want you to do 15 on your own. Okay? So let's look at what she has. What number 13 about Nikki here, running. Nikki just exercised for 180 minutes. 3/5 of those minutes were spent running. How many minutes did she spend running? Now, when you see of, that usually means multiplication. When you have 6 of those, that means it's 6 times whatever you have, right? So, let's say how many of us went to the movies? Well, 3 of us went. Well, it's 3 times. 3 people went. So let's figure this one out. We have 180 minutes that she exercised, but she did 3/5 of that. We're running. Well, 180, I just put a 1 under it. That's all I got to do. Then I look at, can I do any kind of reducing? Well, 180 over 1, that's as small as that's going to get. 3 over 5, that's as small as that's going to get. I can't reduce either one of those. But I can reduce these two. And these tend to, you might need a calculator to do these. Because I know any number that ends in a 0 or a 5, 5 will go into it evenly. Well, this one I know 5 goes into 180 36 times. Okay, so now I still have 36 over 1, 3 over 1. It's getting a lot simpler now, huh? So 3 times 36, that is 108. 1 times 1 is 1. So 108 minutes were running. That's how much time she spent running. Okay. Try the other 3 on your own. Remember, you can always rewind, pause, turn on the subtitles. I believe you can even change them to Spanish if that will help. So go ahead and finish those notes, and we'll talk to you next time.